Hello and welcome to my presentation about the MotionHub, the middleware for unification of multiple body tracking systems. I'll step right into our motivation and the basic problem. There are many tracking systems available, such as Xsense, OptiTrack, Viken, and so on, but unfortunately each system uses different, first of all, APIs and protocols like BVH, VRPN, FBX, or Collada. And writing an app which uses a BTS, a body tracking system, is usually bound to it. And changing to another BTS usually includes additional effort of programming. The second point is the coordinate systems are different, and combining multiple tracking systems is quite difficult. Kinect reports its data in millimeters, other systems in meters, for example. And a third point, the structure of skeletons is different in terms of hierarchy, numbers of joints, or the rotation between joints. In summary, these circumstances lead to a lot of work when using multiple body tracking systems in a project. But there's a quite simple solution for this, which saves time and brings many possibilities. Have a look at the traditional scenario. We have one BTS or maybe two BTS. These BTS stream data to the Unity 3 game engine. If we use a middleware, this is located in between and receives the data of both BTS. And this middleware is our solution, MotionHub. With MotionHub, we are able to address the 3 points mentioned before. We provide a plugin, in our case for the Unity game engine, that has only one API, which means there is only one code snippet for the body tracking that will always stay the same, regardless of what BTS body tracking system is used. Because we have a man in the middle, we can rearrange the coordinate systems, and it is possible to standardize the skeleton data. There are some related applications to MotionHub which were published in the past. UbiTrack and OpenTracker, for example, are generic tracker approaches. They were not solely focused on body tracking and understand a wide variety of tracking devices, but both systems are quite old and not up to date anymore. Also, FAST is deprecated. It was built on the Kinect 1 and uses OpenAI, and OpenAI was acquired by Apple, and the project was stopped. OpenPtrack is the most closely related project to MotionHub in the field of research. Actually, it was not intended to be a middleware. It is rather a single BTS based on RGBD cameras. Today, it supports also multiple hardware and other BTS, such as OpenPose, and therefore can be seen as some kind of middleware. There is also commercial software. It's a Real Illusion iClone with its plugin MotionLive. It supports various BTS and also face and finger tracking, but we don't want to use closed software as its API can change, and additionally to this there is the potential risk that it will just disappear, such as OpenAI did. There are some other minor applications, but at least to the knowledge of the authors, to our knowledge, MotionHub seems to be a unique contribution in this field. MotionHub has potential and benefits for our community, for live performances, for dance performances, for culture, and its open source character may have an impact for bringing low cost but high quality body tracking to the offices and living rooms for entertainment and next level telepresence applications. However, to achieve this, there are some important requirements and subjects of research how to achieve such a software. If you put something in the communication way, which processes and resends the data, the communication stream, by nature, you'll bring in delay. It is important to minimize this delay and make the processing and resending as fast as possible in order to use it for real-time applications. Another important point is that the middleware has to understand each BTS. As a fact, almost every BTS provides a native C or C++ interface as a software development kit, a SDK, and this is why we written MotionHub in C and C++. I will give a short introduction to our software and the capabilities. This is the graphical user interface of the MotionHub. In order to create a tracker, a window will appear and ask which BTS to add. In this window, there's a drop-down menu which allows for choosing a BTS, which is then added here in the video. The user starts the main tracking loop. The green guy is an OptiTrack recording in a loop, which is streamed by OptiTrack Motive. The two yellow guys are tracked by an Azure Kinect. As you see, the tracking spaces are aligned and shares one common floor. If you would bring both systems into Unity, Unreal, or Maya, the spaces wouldn't be aligned. Matching tracking spaces can be done manually in MotionHub by the user interface. Parameters such as translation, scaling, or orientation can be changed on the fly and streamed to the network client. This is here the Unity game engine with the OptiTrack recording, which is processed by MotionHub. And for development and debug purposes, we have implemented a debug view which shows the orientation of the joints and helps with integrating new tracking systems. In order to evaluate our system, we have written a Unity application which we call Human Tetris. In the middle, you see me, I'm tracked by an Azure Kinect, and on the left side you see Ben, one of the co-authors, wearing an OptiTrack suit with 50 markers. I perform a static pose and Ben has to fit this pose as best as possible to win the game. So the results of our evaluation was that MotionHub is easily applicable for real-time applications, and during development it is beneficial at the start as well as later on the project phase. While using the Unity plugin, exchanging the BTS was just removing and adding another tracker during runtime, which only takes 8 seconds for changing between OptiTrack to Kinect. To be able to make a statement about the delay, we've recorded multiple trials with a high-speed camera, as you've seen here, for measuring the delay, which appears without and with the MotionHub in between. We can summarize that using the MotionHub in combination with OptiTrack induces only 13 milliseconds compared to not using MotionHub in between. So our OptiTrack system is capable of up to 240 Hz. We've chosen only 30 Hz in order to be able to make a fair comparison between the Kinect, which runs with a maximum of 30 Hz refresh rate. While using Kinect, we measured 71 milliseconds of delay. One important aspect of the architecture of MotionHub is that each native BTS implementation in MotionHub runs on its own thread and has as soon as new data is available, it is sent to the client by another separate and independent thread. In conclusion, we presented an open source middleware for body tracking, which currently supports Azure Kinect and OptiTrack with Motive Body, and it streams its unified data to a Unity game engine client. And MotionHub induces by nature delay. However, it is usable for real-time applications. In the future, we want to add more BTS such as face and hand tracking to be able to achieve real full body tracking. And the plugin and MotionHub is free and can be downloaded at GitHub. If you find mistakes in the docs or bugs in the code, please let us know. So thank you very much for your attention.